Hello everyone, welcome back to the channel. I hope you guys are all doing very well. Let's see today's daily challenge on Leetcode and we will try to solve it together. Okay, so today's challenge is a little bit counterintuitive. So I will ask you to listen each and every of my word as I say in very detail and very carefully. You will definitely understand this problem. It is not that difficult, although counterintuitive. Okay, so let's see the problem statement. uh, XOR after range multiplication queries. You are given an integer array nums of length n and a 2D integer array queries of size q, when where q's queries of I is uh, Li, Ri, Ki, and Vi. So at first, I hope you have already solved yesterday's problem, which also has the exact same question but with a different constraints. Okay, the constraint was 1e3 yesterday, which is 1e5 today. Okay, and what you need to do is that for L to R within this range. Okay, so you need to process this range queries. For L to R, you need to multiply every element by vi, skipping in a step of ki. Okay, so let's say what you exactly need to do if you are doing some brute force. So from li to ri, you need to skip elements in ki and multiply all those elements by vi. So basically a for loop would look something like this: I equals to l, uh, okay, I less than r, less than equals to r, and I plus equals to ki, uh, this ki value. Okay, and every element, let's say an element ai, you are multiplying it with vi. Okay, v. So that is exactly what you need to do, and for every queries you need to process it. And so while this is what I had told just now, and after processing each and everything, return the bitwise XOR of all the elements in nums after processing the queries. So after processing all the queries, all you need to do is return. Let's say after processing the array changes to something, you need to take the XOR of all elements and return your answer. Okay, return your answer. So return that particular XOR. So this is what you need to do. So if you see, yesterday's problem was very simple. I had given in the post. So I will just go to that problem uh, and I will try to copy that. Okay, copy the solution. So you see, this solution is very simple. What we do, the exact same problem. So what we do here is for n and modulo 1e9 plus 7, which we need to do, we extract each and every query and simply apply a brute force. Okay, from L to R, queries k and v also we extract. And as we told, the for loop, what we do is j equals to l, j less than equals to r, j plus equals to k. We jump steps of k and update each one of them with the by multiplying this value v, and at the end we simply take a XOR. We simply take a XOR and return answer. So in so I will try to copy this problem, this simple brute force solution. But as you will see, this should give you a TLE. Why? Because what is the time complexity of this? When k is equals to 1, you see you will take a lot of small jumps and you will end up in traversing almost the whole array. And if L and R are also very large, so let's say it is covering the span of the whole array, L to R, and k is also 1, in those worst cases, you will end up in traversing the whole array. So Q into N will be your time complexity. The time complexity here is O of Q into N. Okay. And what is Q here? What it's 1e3. N is also 1e3 for this problem. That is why this was an accepted solution for yesterday. But if you see today, it will obviously give you a TLE, because you see the N is 1e5 and Q is 1e5. Okay, if you do n into q, that is 1e10, which will obviously give you a TLE. So if you try to submit this, no doubt about that it definitely gives you a TLE. Now, what do we modify in this code so that we are able to optimize it? So let's see. So first of all, what is the exact issue with this error, with this approach? Okay, what is the exact issue with this approach? The only issue happens when the k value is very small. Okay, so let's say k value is 1. So let's say your what exactly is the problem is that you have some arrays, okay, an array with some elements, and you want to multiply value v jumping k steps. Okay, so if let's say if the array size is something like this and you want to jump big steps and multiply this element, whatever what was this, you multiply with v, whatever is this, you multiply with v, you jump k steps and do it. But if k is very small, then comes the issue, because if k is 1, okay, you are essentially multiplying every element with v, you are multiplying each and every element with v, that is exactly taking a lot of time. So k equals to 1 and k equals to small is the issue currently is that k is when k is small. So let's try to solve, see which case is irritating us the most. K equals to 1 is now disturbing us the most because it does not follow the brute force solution. So we will try to solve specifically for k equals to 1, and we will try to see that what is the issue with that approach. Okay, let's take k equals to 1. So let's forget everything in our problem. You are given L, R for every query. You are given L, R, K, V. Now I am assuming that for every query, the K will be 1. So it means that for L to R, every element you will simply multiply this with V. Okay, so whenever a query will come, you will see L to R range and multiply all the elements with V. Multiply all the elements blindly with V. Try to devise an approach for this. Okay. Now, one approach, if you try to see, is that you try to keep the multiplier, what value is multiplied to each of the numbers. Okay, so let's say you have an array which is something, okay, something 5, 6, 2, 3, 7, something or the other is there in this array. And initially, you have all the multipliers set to 1. So you can have an array called multipliers. Okay, it will tell you what multipliers should be multiplied with each and every element, because you see, let's say this is the first range L to R, you are multiplying each element with V, and then again this range, let's say you are multiplying each element again with V. So as a result, you are multiplying these elements, these overlapping elements of these two ranges 2 times with V, making it V square, or it may be multiple more also. So you keep a multiplier that each element is multiplied how many, what, by what. Okay, each element is multiplied by what. So initially each element is multiplied by single one. Now in order to process these queries very efficiently, what you can do is try to see this as a difference array or line sweep. Okay, what do I mean by it? It simply tells you that if you are given a range from L to R, just mark the L and R plus 1 position. That this will serve as an indicator that you are multiplying the range from L to R. If you are getting confused, you see what we do. We are trying to multiply the value V, right? And let's say the current range tells you something like this. Okay, something like this. The range tells you that, hey, you are going to multiply all the elements which comes in this range with a particular element V. Okay, so how do you change the multiplier? You simply change it with V. Do not update all the elements. Okay, and if this is L, this is R, just the next element you take. Okay, just the next element you take, and this will be V inverse. You just do it V inverse and then again 1. Why did you do V inverse? Because I want to use this as a prefix array. Now if at this point, if someone tells me that what is the multiplier, what you will do, you will try to do the prefix sum, prefix multiplication. Okay, so V, so first element will be V, this element will be V into 1, right? Will be V, again V into 1, it will be V, again V into 1, it will be V. Okay, now this element is V, then again V inverse into V, it will be 1. It will be again 1 into 1. Okay, it will be 1. So I hope you do understand. I hope you know about prefix array. Okay, I am not explaining that. So if you find the prefix array of this, so if you try to find the prefix array of this becomes simply this. And this gives you the exact multiplier. It tells you that within L to R range, within this L to R range, your V is multiplied all the elements from L to R and not multiplied subsequently. So this V inverse helps you a lot. Okay, this actually helps you a lot. And this is kind of acting like a line sweep algorithm. Okay. So what you do now, let's say you want to process another query. Okay, let's say you want to process another query. So as I told, let's process this query, and this is L, this is R. So what we will do, what we will modify in this case is that we will write another array. This time this element and this element is L, this element is R. So we will try to modify L and R plus 1. So we write V. Again, we write a V here. Okay, we change this 1 to V since L is in this position. And we have a 1 over here, we have a 1 over here, we have a V inverse. And again, since R is in this position, R plus 1 will be the next position. So we multiply V inverse again. So now try to find the prefix array of this. Okay, what should be the expected prefix array? You tell me. At first, if you are doing in a brute force manner, at first you process these queries from L to R. So the bottom one, if you process, you will be telling me that, hey, the first 4 elements should be multiplied with V, okay, and the next 2 should be left as it is. After processing this particular query also, you will tell me that this 2, 3, 6, this element should be multiplied with V square, okay, and the next element should be left as it is, okay. So this will be V, this will also be V because the R ends over here. So you should tell me that the you should get an array something like this. Am I getting some array like this? Try to find the prefix array of this. What it will be? I hope if you are clever enough, you have already understood what I mean. So what you do this V, then you are finding the prefix array of this, right? You're finding the prefix array of this. So you simply do V into V square, again multiply V square with 1, again multiply V square with 1, and you multiply V square with V inverse to what do you get? You get V, right? If you multiply these two elements, you get V. And if you multiply V with V inverse, you get 1. So if you see, this prefix array and this array are exactly the same. So in this way, a prefix array of your difference array. So we call this a difference array. Okay. So your prefix array with this difference array is looking exactly the one which I need, okay, to multiply each and every element. Okay, so I want to multiply each and every element. We want to see what is the multiplier of each and every element, and in this way that can happen easily. Okay, now since you have to perform a modulo, since the operations can grow very large, you can perform a modulo. And for inverse, you see, you will say that how will we put the inverse? Because integer data type 1 by v, if we write, how will we perform a modulo? So for this case, you need to do mod inverse. Okay, and multiple time I have told you, there is a theorem called Fermat's little theorem, which tells you that v inverse, if you try to find some modulo, that is equivalent to finding modulo v to the power mod minus 2, okay, whole modulo. This is equivalent to finding this. So basically, if you know modular arithmetic, if v congruent k mod md, then v of md minus 2 also will congruent to k mod md. Okay, so yeah, if you don't know congruent arithmetic, you do not need to worry about this. So it is just I used it as a reference. So Fermat's little theorem simply says that v inverse modulo. So inverse modulo is nothing but mod to the power md minus 2, and this you can find out by binary exponentiation. Binary exponentiation, if you don't know what is binary exponentiation, I have explained it multiple times again in my videos in many Leetcode daily challenges problem. If you want to learn this method, you can search it in the internet also, or continue watching my video. I will also try to explain it. So yeah, whatever be the case, I hope you now do get an idea for k equals to 1. Okay, but now what you will do for k equals to 2? You will say, hey, for k equals to 1, I did a difference array and so on. You explained to me a method which is so long, and you are only telling that it will solve for k equals to 1. Let's see what will happen for k equals to 2 now. We'll try to do the same problem. Okay? But this time, what I will do, I will try to multiply uh, these elements, this difference array, in terms of 2. Okay? So what I will try to jump all the steps by 2. So what I'm doing, initially the multipliers were 1. Okay? And what I did, that from L to R, since all the ranges are considered, I did L and R plus 1 simply. But now I need to jump k steps within this range. Okay, now I need to jump k steps within this range. So let's say some elements are over here, and from L to R, you need to jump in steps of k, steps of 2, let's say. And let's say your last step is somewhere here and it is jumping exceeding to R. Okay, so what you need to do, you need to multiply a v with this element, you need to multiply a v with this element, you need to multiply a v with this element, but not this element. Okay, so you need to, in your difference array, you need to place a v over here and a v inverse over here. Okay, so you need to see what is your step size, which is k. Okay, and yeah, and like how exactly you need to multiply this. And while also you are making a prefix array, you see, whenever you are also making a prefix array, instead of multiplying all the elements, you just multiply the elements in steps of k. So what do you do in a prefix array? You do prefix is equals to prefix, let's say for this particular thing, prefix I minus 1 into this particular nums or whatever difference array, whatever array you call it, right? You're multiplying in that way, nums of I. What you do now is that you calculate prefix of I in prefix of I minus k, and then multiply with nums or array or whatever the ith element. So your prefix calculation will also change. Okay, for k equals to 1 to k equals to 2, these are the changes in your prefix calculation, and this particular change is the change in your multiplication of v and v inverse. Okay, but if you try to see this approach, if you try to see that if k is very large, then what will happen? What will happen is that you need to make this prefix array again, right? And there will be a lot of difficulty in making the whole prefix array, because there will be a lot of jumps, right? This number of jumps will increase. So what I'm telling is that within this L to R, you are not considering every element, and therefore you are keeping an account of the jumps. So if the jumps are very large, the distance that you will need to know between them will also increase, and it will be difficult to calculate this whole prefix array. So what do you do? In the two approaches, what do you learn? One was the brute force approach. Okay, one was the brute force approach, which tells you that for k very small, there is an issue. Okay, problem. Okay, you cannot do it. So creates problem. And it also another difference array method which we learned just now. It is for k equals to small only. For k equals to large, this creates a problem. So we will try to combine the best of both worlds. Okay, so how can we do that? Crude method will be 2. see whether k, see k is going from 1 till n, right? This is the range of k that you can receive in your query. So if we see that the this particular k, if it is less than root n, okay, then we will try to follow this approach. And if it is greater than or equals to root n, we will try to follow this brute force approach. Now, why exactly I am selecting root n? This is a little counterintuitive, but if you try to see the time complexity for this root n, you will see that if k was always greater than root n, if this constraint was given to you, then even the brute force solution does not faces any error. Why? Let's try to see. If k was root n, first of all, our time complexity, what was it? It was O of n into k. But if k was told to you that it will be root n, okay, so our time complexity will change to not n into k, sorry. Uh, your time complexity was queries into n. Why n? Because if k is 1, you will have a loop of n over here. Now, if k is root n, you are jumping steps of root n, okay, and you are essentially total number of steps would also be less than or equals to root n. Okay, so the worst case time complexity will be root n in this case, not n. Since k cannot be 1, you are telling that k is greater than root n, so time complexity will be O of q root n. And if you try to see, q is 1e5, root n is approximately 1e2 point something, okay, 1e2 you can say. So 1e7, approx value of 1e7 time complexity works, okay, it just works. So that is what I am trying to say, that when k is greater than this value of root n, you can try to apply a brute force solution, okay, and when it is less than this root n, you can try to apply a difference array solution. It will work just fine. So let's try to do the coding, and then we will gradually understand what is all the issues and how do we exactly take care of that. Okay, so let's see how do we do that. So we will have a variable limit which we will call as sqrtn. Okay, so square root of, this is what we have. We are trying to modify this approach only. So after all this, we would like to process the queries. Okay, so what are these queries? So we will try to group the elements by values of k at first. Okay, we will try to group the values by k. So, and it's the same k, we will process the same number of times. So you see, for the same k, you follow a same pattern, right? So if k, you have a value of k, so it tells you from l plus k, l plus 2k, wherever r is ending, just before that, whatever will be the value, you just need to calculate those elements, multiply with v to those elements, right? So for the same value of limit, I want to perform a very similar operations. So I want to group by values of k. So group by values of k. So I will try to create for doing this, I will try to create a map, okay, an unordered map kind of thing, where k is nothing but the key, and the values I will try to put as L, R, V or whatever. Okay, values can be something like this will be the key, and L, R, V. Let's see what to do. L, R, V. I will try to put it as the values. So I want to group all the elements uh, by this key comma value pair. So for that, of course, I will need a map, unordered map, int comma vector of int. You will understand why I am doing like this, and I will call this as a map. Now I want to go through all the queries. I want to process L, R, K, V, all the 4 queries. Okay, and this is the thing which I would do if this limit, okay, if this limit, if this k is greater than limit, okay, k is greater than the root n, so whatever algorithm we this brute force algorithm is applicable when this limit, if this limit happens to be, if this k happens to be greater than equals to limit, then only we are saying that I will process in a brute force manner. Otherwise, I will try to do it in a difference array manner. Okay. So else I will try to first group the values by k. Okay. So map of k will be what? I will try to push the, let's say, push back the whole query. Okay. L, R, V values I want to push back. So that will be a whole query only. So yeah. Uh, So each k value can also contain multiple query, and each query is a vector. So that is why a vector of vector is what you need to push over here. So queries of I can put it over here. So yeah, that is all. We now have the grouped by queries ready. We just need to process these groups, okay? And that will be just fine. So let's have a loop which will just iterate, let's say auto key comma values. So key comma value is nothing but query. So key comma query in this map, I will try to iterate. Okay. And as told, I will have a difference array. Let's try to have this difference array as long because we are performing modulo and many things. So yeah, try to make it long. And I will call this as a difference array of length n and initialized to 1. All the elements in initialized to 1 because that is a multiplier. You can call this as a multiplier array also. So now what we do for every query in this particular k, I will try to process it as a very similar manner. So for every query in this particular k, I will try to process the values. Okay, so at first I will just extract these values of L, R, and everything. Okay, so L, R is nothing but Q of 1, and V is nothing but not Q of 2, it will be Q of 3. Okay, so L, R, V, we take it. So now what we do, multiply, we will like to multiply the starting position at first. Okay, as we told that if you remember this approach from L to R for not k not equals to 2, k for any small k, what we do, we multiply the first L value with V, and for V inverse, we try to see where is the next R value, where is it exceeding the R value. Okay, we try to see for that. So initially at L, we will try to multiply. So difference array of L will be nothing but this difference array of whatever L is there into V. And you will, of course, try to have a mod of this. Okay. Yeah. After you have a mod of this, what you do, you see, you need to find out at which position this V inverse is present. Okay, V inverse at which position I should multiply. So let's try to calculate a value of next. Okay, what will that next be? That next will be nothing but R minus L whole divided by K. Okay, plus 1 into K. Can you guys, can you understand what I'm trying to do? So what I did, I tried to find this is the step size. Okay, this is the not the step size. Step size is k. So if you divide r this range by your step size, so you have this range L to r. If you divide that by your step size, you will get that what is the number of total number of steps what you do. See, k was the step size, so this tells you the total number of steps. So you can write this as a separate value also. Total number of steps is nothing but L minus R. r minus l by k, and you want to take one step more than the total number of steps. Why? As I have told you, from L to R, what we did, L to R was here, so V inverse we placed above R, right? So for K not equals to 1, what we do as a general manner, as we are skipping K terms, we need to see that what is the last element where we skipped R, okay? So one step more I take and I multiply by the step size. One step more I take and multiply by the step size. That way we get the next index number. Now if this next index number is less than n, then only you have to do something, right? What you do? You just multiply this. Instead of v, you multiply v inverse, okay? Instead of v, I will simply multiply with v inverse. So difference array next will be nothing but difference array of next multiply with mod inverse. I will try to write a function which will calculate this mod inverse value, and this will be, let's say, mod also I will pass. And after multiplying whole mod also I need to take, right? Whole mod also I just took it, and you see now you have processed all the queries for a particular value of k. Now you find the prefix array of that and just multiply that. That is all, right? So you need to find the prefix array of, find prefix array to get all the multipliers. That is what, okay? So for this particular value of k only, so for int I equals to 0, I less than n, I plus plus, if I is greater than equals to k, what you do? You try to do difference array of I. You just do the prefix array only, but in a bit different manner. Difference array of I minus k. Okay. Perform a whole mod, and whatever multiplier you are getting, where you need to multiply this multiplier with this nums array, right? This, because in a brute force approach, we had already edited our nums array. So now for this, I just need to have nums of I equals to let's say long of nums of I multiplied by difference array of I and a whole module, okay? So particular multiplier of I will get multiplied with a particular number of the array. So you guys see, that is all actually. It is all. All you need to do is now apply this mod inverse function. I hope that you can easily do. As I told you, with this Fermat's little theorem, this mod inverse, V inverse is nothing but V to the power of mod minus 2. So all you need to calculate is V to the power of mod minus 2. This is what you need to calculate, right? This is only nothing but the mod inverse. So this long mod inverse, if you try to calculate with long value of n, you can do as define ll long also. I did not do that. I should have done that, but yeah, whatever. Int mod, and you need to return, let's say, binary exponentiation of binary power of 10 to the power mod c. Mod is a very large number, 10 to the power 9. You cannot use even a linear operation to multiply this. So you can't say that, hey, I will just multiply this mod minus 2 number of times. Okay, you have to do it in a binary exponentiation fashion, which takes log n times to multiply. Okay, so binary exponentiation of, let's say, a to the power e. A to the power e, I am just calculating. Okay, a to the power e. So how will that look like? So I will just quickly tell you about binary exponentiation. I have told you multiple times, but still, just quickly go through it. If you do not know, I will suggest you seeing in the internet also. So what we do, let's say we want something like 6 to the power 11. One obvious way is to multiply 6 11 times. Okay. But in binary exponentiation, what you do, you write the binary representation of this 11, which is nothing but 1011. Okay. You write the binary exponentiation of this 11 and you iterate through the bits of this 11. Okay. So whenever you get a set bit, so at one you just keep that whenever this 6, you keep multiplying it. Okay. So 6 square. So just telling that 6 to the power 0 or 6 square, 6 cube. You just keep multiplying like this. Okay. And whenever a 1 is there, you just take those values. Okay. 6 to the, this is not 6 square. So what I would like to do, 6 power 1, 2, 4, and 8. Okay. 6 to the power 8. Yeah. So in every operation, you just keep multiplying 6 with itself. You just keep squaring the exponent. So yeah, what I'm trying to say is that whenever this 1 is there, you just take those values. So 1 is there whenever you encounter a set bit, you just multiply that one. 6 1 you encounter a set bit over here. Now 6 to the power 2 also you encounter a set bit over here. This you do not encounter any set bit. If you encounter a set bit over here, just multiply 6 power 8. And you see this is nothing but 6 power 11. So this is nothing but a shorter way to multiply. Okay, any large number 1 in 9, you just express this in the number of bits and you just traverse through the bits. If a bit is set, you just multiply that value with your result. Okay, so yeah, that is what exactly you need to do. Long result, let's say you initially have it to be 1. So while this exponent value is greater than 0, all you do is keep right shifting this exponent by 1, and you see if you have a set bit, it means that you just do AND with 1, right? You do AND with 1, tells you whether the last element is 1 or 0. So if you have a set bit, what you do, you update your result. You update your result with this A. Okay, modulo, and this is also result, and A is anyways long. So yeah, no problem with that. And yeah, you do this, and otherwise for every step what you do, you just do A equal to A into A. So it will ensure that you are doing 6 square, 6 power 4, 6 power 8. These values you are just calculating no matter what. So for every time you are calculating values. So yeah, and you are also shifting this exponent. At the end, you just return result. So that is all. That is all you have to do. You just calculate this v to the power mod minus 2, which is nothing but v inverse. And I hope the solution was already very clear to you. Let's try to submit this and see if any kind of debugging we need to do. Uh, yeah. So binary exponentiation of mod. I did not define mod here. Yeah. So that is what. Okay, this is MD, right? Not MOD. So let's see now. Yeah, we did get the accepted thing. Let's try to submit for all cases and check. I hope this will be just fine. Okay, so yeah, we are getting a wrong answer for a large test case. Probably somewhere mod or something we are missing out or something. Some issues are there. So we'll try to see in detail what is the issue. So first I will try to check this function, and this is, I hope, is pretty basic and pretty okay. There is no issue with this mod inverse and all, right? So yeah, next we have this XOR after queries function where we have the limit to square root of n, which is just fine. We have this unordered map. It's nothing but storing the values of k and all the queries, right? Yeah, so after this, queries, what you do, you iterate through all the queries, extract the LRKV values. K is greater than limit. You apply a simple brute force solution to this, where you simply multiply in the nums of j with that particular value. Else, what you do, you push back the queries into your map, okay, corresponding to the K. Now you take K, okay, and for every queries you extract only L, R, and V. Yeah, this is also particularly fine. And difference of L, you at the position L you multiply value V, okay. At the position L you multiply value V, and you are taking steps of LR minus L by K. That is also perfectly fine. This is nothing. Okay. So I guess you missed something over here, right? Is L plus not just the steps, not just the number of steps. This is the offset, right? Forgot to add this offset. Offset with this particular value of K. Okay, so this is your next, right? You take one more step, but obviously you start from L, right? Start from L and take one more step, multiply it by K step size, and it was this all? Was this all? I will try to just run for all cases once. Wait a second. Let's see if this was only the error. Yeah, see, yeah. Now we get the accepted thing. Yeah, that's all. That's all for this video. I hope the solution and everything is pretty clear to you. I tried my best to explain it, although the solution is counterintuitive. Tell me if you get to understand. If you are confident about this problem now, and you are confident to apply a similar kind of idea in some other problem, just let me know in the comment section. So I get to know that yeah, you did understand something. So yeah, that is all. If you have any doubt, that also you can post it in the comment section. That's all for this video. I will meet you in the next video. Till then, thanks a lot.